So let's start the afternoon with this feedback on NoSQL on schema design. And I like to start by turning on this thing. And introducing myself. This slide has two purposes. One of them is to present myself, and the other one is to give you a few minutes to get used to my accent. So I'm coming from France, and I work at Mapar as a technical evangelist for Europe. So my job is to not only come to conferences, but also help developers, users of the platform of Mapar, big data platform, or Hadoop globally, or NoSQL to adopt the technology as existing user or just simple discussions. And also work closely with our engineering team to try to improve the product to make the life of your on a daily basis as a developer, as an architect, easier. And some of the feedbacks that I will give you today are based on a real-life discussion we have with project teams. And if you look quickly on my very short resume, I come from an application and database developer. Before Mapper, I worked at MongoDB on Couchbase, but also as for many years at Oracle. So why I mention Oracle here, it's because I switched from a pure relational SQL-oriented developers to something totally different that is NoSQL. And for many reasons, and we will discuss about these different reasons why it's interesting and how we can achieve that. And the main reason you will have new data store like NoSQL, it's because the volume of data that we have to capture, we have to process, we have to analyze and use in our application is growing very, very, very quickly. And not only it's growing very quickly, it's also unstructured. It's not simple rows and simple columns, but it could be data coming from user clicks, data coming from social medias, and so on. So the volume of the structure of the data that you have to deal with in your application is changing and growing very, very quickly. And this is why you have many big data platforms that has been built, the most famous one being Hadoop. And when you talk about Hadoop or Mapar being Hadoop plus some added value regarding NoSQL, streaming data, management of the platform, you usually look at two different ways of storing and organizing the information. One of them is to use the file system. You can store anything you want in the file system, any type of files. So you can, for example, use this to store all the log file of your applications, all the servers, all the log files of your application. And the way it's done when you look at the big data platform, it's distributed on many nodes, and you can scale out as much as you want. So this is the purpose of HDFS, so Hadoop file system, or Mapper-FS, Mapper file system. But you also have another way by default in Hadoop to organize the data using a NoSQL database. The NoSQL database in Hadoop and in Mapper, it's HBase or MapperDB. How do you choose between one or the other? It's very important. So one of the first things you will do when you build your application that is targeted to big data and to deal with big data, is to choose how you want to organize the information. And most of the time, in a system, you will mix the two different data stores. But today I will focus on NoSQL. But let's see quickly how you choose between one and the other. In the file system, you store files. You can store very, very big file if you want, or very small file if you work on Mapper-FS. It's very efficient if you have to scan a big, big part of the information. But you just scan this information. But if you have to access a specific piece of information in one file, when you have terabytes of data, just to read or to update, the file system will not be the most efficient way of doing this. Where you look at the NoSQL database, you can store anything you want in terms of rows or JSON documents. And it's very efficient when you want to access a specific random document or a specific random row. So you are looking for a specific customer on his ID. You just select the ID, and you will directly go inside the good location inside your tables. So if your application needs to do a lot of read and write, and on specific, for example, updating a customer, updating some information about the profile of a user on your website, you will probably use a NoSQL engine. If you just want to be able to store a lot of log information and process that using reading every night all the new entries, you will probably work with a file system. So when we talk about NoSQL, the first thing on this specific talk is not about the architecture and how do you scale and so on, but more talking about schema. If we look at a relational database, we have been used for many years to develop or to define ERD, so entity relational diagram, that expose the information of your system into specific entities that you will match on tables, specific attributes that you will match on columns, and so on. And it's great. But let's see why we need a new way of organizing the information. So the way we have organized the information between NoSQL, at least in the context of Mapr and Hadoop, is you organize still the information by rows, but in relational database, you have very specific types that you have to define for each column. And each row in a specific table have exactly the same fixed and uniform structure. In many cases, when we look in real life, when we are talking about one customer or one product, the number of attributes, the number of fields could vary between one customer to another. This is one of the reasons the structure is flexible into NoSQL engine to make the life easier when you have to access or when you have to organize information. So no predefined structure. To access the information, to make it very, very efficient in read and write, you have a single key by default in HBase and MapRDB, where you can create many information on many indexes in relational database today. And a part that has been very successful in relational database is referential integrity that you can activate. And we will see the impact of this. So referential integrity being you have two tables with two different information, an order and a line order, and you have a relation between the two of them and a constraint to be sure that if you try to delete the order, you will have first to delete the line order, for example. And one of the important parts also when we talk about informations is to represent complex data. To represent complex data, it's very often to mix different models on information. You want to be able, if you have a list of value, you have a profile and you want to organize this user profile using specific tags or list of center of interest, easily you want to store complex data. So using, for example, JSON documents inside an attribute or a list of value, it's something that you can do quite often. You want also be able to deal with references between different objects. And usually in NoSQL, what you will do, and I will come to that in a minute, you can include in this reference between an object and all the sub-items into a list of value in the same row. So you will organize complex data into these tables this way, but you can also, inside a specific table, inside specific attributes, we add more complex information. Let's see some example of this organization. So when you look at the way you want to organize the information, you have two different ways. Most of the time, we will look at rows, when you have one single information with many attributes, or many columns, column 1, column 2, column 3. Or you can organize also that as a list of value with columns by columns. When you want to mix that into a single schema, so if you look at the way you organize information, for example, using JSON, you will see on a row-wise, you have one row with each value, C1 value 1, C2 value 2, Another way of organizing the information will be to have, for each row, you just store the column name, and the value 1, value 2, value 3, and so on. Depending on how you want to access the information, you organize this. So if you want to scan on the specific columns because you want to make it very efficient to calculate the average price of something, it will be more efficient to read this because you can read in one single access to a key all the information. So depending on how you want to deal with the data, you organize the schema differently. And typically, this is something we use quite often when we talk about time series. So time series are here to deal with many information, many entries with many, many values. So every time you have a sensor, for example, yesterday Ted did a presentation about cars and getting some metrics from the cars. This is a time series. Every time you have a sensor sending data, you have many information to process and to store. So one of the nice parts about NoSQL, the column names are not predefined. So the list of attributes, the list of columns are not predefined. So you can use that as an information. So you can, for example, use a time offset as a column name to store the information. So let's see with a concrete example. So if you want to store the information, for example, for a time series information, and it's a very, very simple view of a time series database. In this case, you will have, if you are working in a relational database, you will have the time series ID, a time, then a value. You must organize this information like that when you work with a simple relational table, because you don't know how many ticks you will have. In this case, we have at 51 3 seconds, 52 7 seconds, 52 11, but maybe we can have many of them between, or depending on the sensor. The issue with this, you will end with billions of rows containing very, very small information. If you want to do aggregation, calculation, it's complex, it's a lot of processing, but also it's not efficient in terms of storage. So another way to organize this information when we talk about NoSQL is to use the fact that you have flexible columns and flexible attributes. In this case, you still have the sensor, but you use the time window, at least the start time of a time window, as part of the key. So for the sensor 101, at 3 p.m. 51, we start, and every time you have a new tick, you look at the second, number of seconds after 00, or milliseconds, or depending of, in this case it's seconds, but depending of your application, and you put the value. So in this case, for 1 minute, we have a single row, and you can have many, many, many entries inside this specific row. And you see here we have the second row for 52 with 2 values, plus 7, so it was at 52.07, and 52.11, you have different values. A lot more efficient in terms of storage of the information. And you can also reorganize this information to make it even more efficient in terms of storage by aggregating this into a list instead of having all the columns. So this will look this way. So we compress the information for a specific key. We just reorganize the information. So the same information as before, but now at T0, the value is 001. For the second row at 52 seconds, at 7 on 1, we have 004 and 008. So you can really reorganize this information. Keep in mind that this specific time series database are used, or this organization are used when you have to deal with billion, or let's say million of messages per second, if you want. So meaning billion of information you have to store. And more importantly, when you work with a time series database, you don't modify the value. If you have a sensor that has been emit some data, you will probably not change this value, because this value is what is coming from your specific healthcare pump information or cars information. So it's an immutable data that you can use and organize to make it more efficient. So typically, for a time series database, a NoSQL database that is organized by columns, it's very efficient and very powerful in terms of storage. You have to be able to query and process this information. Another example is to use a more classical application as an example and see what will be the benefits of switching to a NoSQL engine. For this, we use a database, a public database like it's called Musicbrainz, that contains many artists and many albums and many information about the artist and the albums into a database. And it's a relational database. You can find a model for Postgres, but the idea is to move from this relational database to the NoSQL engine. And you have obviously some key information like the artist, album, tracks, labels, and key other objects. But you have many, many other information. But if we look at some of the key information, you will have lot of information distributed in many tables. But I will take very few examples, very basic example about artists and their albums and songs. But if we look at, for all the information, you may have ended with 138 tables containing all the different information for an artist, a tag, the alias, and so on. So the relational table for this, the schema looks like that. And the reason why I'm showing that, it's first to show you how it's represented, but also because you often have a discussion between people that come from relational and say, yes, when you have a schema, it's a lot easier to read. When everything is defined before, it's easier to read. It's not, because 138 tables is just for artists. If you look for very complex data store, like an ERP and so on, I think SAP and Oracle will have 20,000 tables. Schema, table names, or schema or not, will not help you to find the information. You have to understand how do you access the information, whatever the database you will be using. It's true for a NoSQL engine, and it's true for a relational database. In addition to these tables, you have many tables coming from the schema on Musicbrainz that could be used for many information. But let's try to simplify that. So today we have 236 tables to describe 7 important things. And let's focus on this. So this important information will be the artist. An artist could have multiple aliases. The type of aliases, is it a group, is it a nickname for a specific date, and so on. The artist type, the gender, then some key values, some IDs about the artist itself as a database. So if we look at what we can do, is first we take all the relation in one single, in the same table using list. For example, we have the list of aliases here, the list of recording here. So in this case, in one single table, you have all the information. You just have to organize the data differently. So, and you do the same with all the other tables, meaning you will take, for example, for a specific release, you will have the type of medium it is. It's a CD, it's an MP3, and so on, and you will put that in another table. So you kind of aggregate all the information in a single row to simplify the management. So we were able to reduce at the end, when you look at artists, alias, albums, and so on, to only 4 tables. And you can continue more and more on this. And when you access one single information, you will be able to get all the information in one single query. I will show you an example of artists and albums in one single row into HBase. So the way you will do in this case is you will have the ID. So the artist HBase table is called Nirvana. And if you look at it, it's one single row organized with the different attributes. Keep in mind that you can have many, many attributes as you want. So HBase, by default, will represent the information this way. And here, in this album list, we have a list of value as JSON. just to make it easier to organize the content. So you don't have relation officially between different tables, but you can do that in this context using embedded list into one single row. So what you see here is I use a mix of columnar-oriented information, so all the attributes, on JSON document. So what we see on the market of the NoSQL today is you have very scalable databases, and you have less scalable databases usually that are document. So scalable using binary API, performant, very direct access to the information has been proven like HBase on the market. And what I like as a developer, and probably you also like, is the fact that working with documents, it's self-described, it's very easy to manipulate. So the document database has been very, very successful for a medium-sized project. But the vision we had at Mapper was to try to mix the two technology to make it very efficient to scale, but also easy to use as a database for the developer using a JSON-oriented, so a document-oriented database. And for that, let's see how we can achieve that and talk about the OI API that is used to build applications. The first thing, what about JSON? Why JSON? Support data type. And this is a very important part. For people that have used HBase, HBase just simple store columns without any information. It stores bytes. You have, as a developer, to know what you want and what you are reading or saving. In this case, you will have the type of data plus a defined structure, but inside the document. It's not the database itself that validates the schema or check the number of columns and so on. It's just the document you save. And it's very easy to make some update on the schema and the data structure, and I will take an example. So data types, the name of the attributes. You can have complex data structures or nested document here. You see an address or a list of value. And numbers, date are supported. So you have many, many use cases where database has been, NoSQL database has been very, very successful. And a few examples. And I took this list of type of application from a book from Martin Fowler, NoSQL Distilled. At the end, he presents that as a resume, as a summary. And I took two examples about MapperDB JSON and MapperDB HBase, so MapperDB or HBase, and which type of application will be the best for each database, or which database will be the best for a specific use case. And let's dive into one of them, the product catalog, to show you the benefits of a JSON-oriented database. If you look at an e-commerce platform, and you have big specialists here in Berlin, when you look at products, you have many, many, many products. The issue is you don't realize that a bike, you don't know. You know that a bike and a set of tires don't have the same characteristics. It's a product. They have a price. They have a brand. But the way you describe a bike and the way you describe a tire are totally different. So usually in the relational world, the way you work, at least for people that have built product at the top of that, it's to use a complex pattern called EVA, entity value attribute pattern, where you have multiple information like the product, and I will give you a very simple access. The product, the list of attributes, and the list of value for each attribute for this specific product. In reality, if you look at, this is based on Magento, so one of the open source e-commerce platform. To get one single product, this is the query you have to create. Obviously, you don't create it, the API does it for you. But keep in mind that the engine, your application, has to do that. To be able to be efficient with this kind of query, you will have many caching layers everywhere in your application, with the challenge of when I have a product that is updated, a new product that is published, or one single attribute that has been changed, how do I invalidate my cache, and so on. Using a NoSQL on a document approach, you can completely change the way you access the information and you organize the information. Just describe the product in a single document. And you have an ID, the name of the product, and you do a find to get it immediately. So just here, even with no volume, no complex, no million of users, it will be more efficient. But imagine if you have all these million of users, million of product in your application, in your on your website. And also, as me as a developer, I see the business object product. It's very simple. I can read it directly. It's stored this way, at least from a logical point of view. And when I find it, when I search it, I can immediately understand what it is. And a key part also is the flexibility that you need when you have this complex data. On a single product, on a single table product, you can organize the different product using different attributes. So you see the top 5 attributes are the same for each product, an ID, a name, a brand, a category, a type, and so on. And here, the second set of attributes, it's in a single document, are just specific value for this specific type of product. So very easy to organize, very easy to add. And one of the key parts in this case, working with a document database, you will have easily updates in terms of modification of your application, your business requirements, and so on. So the backend data will match very quickly the front-end expectation, and more importantly, the user and marketing expectation. So for example, if you want to add new information, for example, marketing is coming with, now I want to be able to add comments and rating to any of the product, you don't need to change all the rows, you don't need to change all the documents, you just add the feature in your front end and store the information as new attributes. And if this jersey is the only product that had comments and rating today, all the other attributes, all the other products in your database won't have these attributes, and it's okay. It's efficient in terms of storage, it's efficient in terms of development, because it makes the application update, so the time to market very, very quick to adapt to change and to business requirement. So if we, so the JSON document made the data modeling easy, and for this I was coming back to the first example of Musicbrainz application. When we look at the HBase example that was this way, you had few attributes, except that you have a complex way of manipulating the data, the same information in JSON. And if you look at it, I do a find into a database, into a table, artist.json, so it's real-life data. I just use exactly the same information, but organize the data using a JSON document to make it easier for a developer, for a user to access it. And when I say easier, think about how you build application today. You build probably microservices, or you're trying to go to a microservices architecture when you want to expose API, where you want to expose REST API to the user. This is more or less exactly what you will send as a contract to the other application. And same, if you want to have flexibility, if you have new attributes, it will automatically be available. If you want to save new attributes, it will be very easy. Obviously, you will put a business layer to validate the value, validate the type of data. But from a database point of view, the constraints are not slowing down the process of development. So the way MapRDB JSON has been built, to try to give you the key point when we are looking at which database do I need to use to develop my application, it was to be able to work with a very scalable database. In this case, it's really when you want to capture many information about user on one side, you will use, for example, a file system to click all the logs, or you want on the same platform work with your product catalog to avoid to have another cluster with another database. So you will use, if you want, Mappa, and you will have specific way of organizing the information. For example, column families will be to organize the data on disk in a specific way to make IOs very efficient, very scalable when you scale out, when you add new servers, and also put very fine-grained security. If you want to store some information about credit card and so on, you can encrypt them, but also be sure that only specific user will have access to that in read and write. So column-level security. And very often when we talk about JSON, and remember the good XML time, it was the same kind of discussion, the data are expensive, are big in terms of attributes and so on. On disk, the database doesn't use a string as a JSON string. As soon as your API will hit the network, it will use a binary format. On disk, on the network, it's a binary format that is very optimized, that still keeps the information about data type, but also the way the OI API has been built, MapRDB being one implementation of the backend, but you can use that of any type of process manipulating JSON. It uses all the data type you have in Java. So if you have a big decimal, if you have a simple float, and so on, it is stored this way, not as a simple number in JavaScript. And as mentioned before, one of the key parts is we love JSON, at least I do love JSON, because it's very easy when you want to develop. It makes you very efficient to manipulate the schema, add, remove attributes, do some increments if you want to manipulate. So because we know the type, you can easily do an increment on a number and so on. And the way you will see an application on some Java code will look this way. There are two examples of manipulating in updates or insert of the data. So you can either obviously send a complete JSON string. I will start with the top. So you have a JSON string in Java, in Node.js, in Python. You can save it. Or if you want at the top, use a specific attribute. So I will create a document. In this document, I will add a new sub-element, and I will insert this as a document in my database. And if you want to update, you will have specific operators like a mutation. So one of the key parts, true for any application, that especially when we are moving now with a more fine-grained services-oriented application, it's you want to be able to do quick development of the first version of the product and be sure that, or your services, and be sure that the database schema doesn't slow you down, so you can quickly update, modify, and enrich the information. And do the update, you can always update on going back. You can remove or add columns, attributes if you want to. And keep in mind that in this case, in most of the NoSQL engine, you don't have complex transactions. That means when you modify a structure of a document, if you remove a columns, if you remove an attribute, it doesn't lock the database. So you can continue to work in a very efficient way. The flexibility is very important. And I will just want to jump on this. One of the important parts is developing the application is easy. One of the weaknesses in most of the NoSQL database, it's all about everything you want to do around analytics. How do you do complex query? How do you do calculation? How do you do aggregation? Most of the time, if you want to do that on a NoSQL database, you must program you must code. But everybody, I think I will say everybody, but at least for sure, every analyst today in an enterprise know how to write SQL. So SQL is really the language you use to do analytics. If he doesn't know how to write it, the tools that he's using know how to do it. So all the business intelligence tools. So one of the key parts when you look at NoSQL, and any type of NoSQL, it's to be sure that you can access it with SQL. So the SQL on NoSQL is one of the very important parts of your system. And I have to say that I do more SQL today than when I was at Oracle. Because when I was at Oracle, I was doing everything in Java, so I was not seeing I was not looking at any SQL. And I will give you two examples of querying HBase or MapperDB binary using Drill. Drill being a distributed SQL engine at the top of everything. It's not a SQL on a Hadoop, because you can run it on standalone on your laptop, and you can access many, many data sources. Your distributed file system, on your NoSQL databases, but also many other databases, including relational database. As I said before, when you work with HBase, the information inside the database are simple bytes. So you have to convert each column, each value you return, using a convert from functions from UTF-8 in this case, to be able to get the list of artists on the list of album. In this case, if you look at the t.list.album, so this is an album attribute that contains a JSON string. Drill is very powerful and have a lot of out-of-the-box function. One of them is to convert from a string, from a byte to a string, using the convert from. But because it's a JSON document and I want to be able to manipulate that, I even access to a convert from JSON if I want to manipulate the information. Very powerful in this case. If you work directly with a JSON-oriented database, for example, MapperDB, JSON, or MongoDB, you can simply query and get the attributes. This information, this query, or this one are exactly the same in terms of result, except you organize the data differently. In one case, the JSON document contains already the attributes, the type, so you don't have any conversion to do. And with Drill, you have all the capabilities of aggregations, group by, having, order, subqueries, and join if you want to do complex analytics. So this allows an important part when we talk about this, not only this data structure, but how you will be using your database. You don't need, when you work on a very large database, you don't need to copy the data in a Hadoop cluster in a different format. You can query and do all the analytics directly where the data are stored. So it's in this case, you have a single cluster containing some data in a file system, for example, your log file. On the same cluster, some information about your product catalog. On using Drill, you will be able to do a join between your file system and your NoSQL engine, and maybe do some lookups in your old data warehouse. So very powerful as a way of querying data, even in NoSQL databases. So something that I didn't mention in detail, because it could be, we could talk for 1 hour about IDs on the way you organize the information. When you work at scale, depending on how you access the information, read or write, the way the database, HBase, MapperDB, JSON, the way they organize the information on disk, and also on different servers, it's using the raw key, or the ID of the document. So you have to be careful in the way you organize the information to distribute the data properly. And when I say distribute the data properly, it depends on what you want to do with the data. This is you design for your application. Because if you want to only write very, very efficiently, you will try to distribute the write on all the machines, like that you can scale. But you also have to be careful in the way you want to read the information, because if you want to be very efficient when you scan some information, you want to be sure that the data you get out of the database are ideally on the same place, because you don't want to start on one node, go on to another, go back to the other node. So this is why when we talk about distributed database, NoSQL database, the way you distribute the information using the ID on the raw key is very important. Every time you modify one single row, and it's true for HBase, MapperDB, JSON, or Cassandra, MongoDB, the update is atomic. If you modify one single attribute, it's either the full row or the full document will be saved, or it will be canceled. You don't have multi-document transaction. You don't have foreign keys between different tables. For the main reason, it's performance and scalability, because every time if you want to deal with complex transaction or complex management of 2 different tables, you need a lot of machinery on the server to distribute that on many machines. Think about scalability. So for this reason, you don't have complex transactions, but you have updates on operations that are done atomically, on a single document and single rows. And the way you organize your information give you transaction. If you have an order on a list of items in one single document, you can do everything you do on a relational database. Also, the way you organize your information will be using pre-aggregation. You calculate and you try to do as much as you can on a single row to be very, very efficient, especially when you are at scale. Number of users, number of documents. So, thank you. If you have we have a few minutes for questions. One question.
Thank you for your talk, Doug. With a heavy heart, I have to say that we can't allow any questions, but they can if you have any questions, please take it offline.
I stay all day, so.
All right. Thank you, ladies and gentlemen.